Good evening, ladies and gentlemen. My name is Ashley Helm, and this is my honors project presentation. The idea of my experiment was originally found on a science project website. However, I elaborated upon their fairly simplistic idea. My elaborated idea was to use seashells, saltwater, and vinegar in order to test the effects of ocean acidification on calcium carbonate shells. I would vary the amounts of vinegar to see that if a higher concentration of acid had a higher effect on the seashell. As with any good science experiment, my experiment began with a lot of research. I researched for 3 reasons. 1, it was required. 2, I needed background info in order to better understand my own experiment. And 3, I needed to make my experiment as accurate as possible. One of the things that I needed to research for accuracy was the salt-to-water ratio of seawater, so that I could accurately recreate it in my lab. A couple of things I had to research in order to understand my experiment better was A, how carbonic acid got into the ocean in the first place, and what role climate change played in all of it. B, what ancient acidification did versus modern acidification. Spoiler, ancient acidification was much slower than modern acidification and allowed for the species to adapt to the new acidification. The rate that it is happening today does not allow for adaptation, and that could spell trouble for organisms in the future. Finally, I had to research the effect of acidification on ocean organisms. That was actually my research question, and since I ended up answering it, I had to modify the question in order to have a hypothesis for my experiment. Now we're getting into the fun stuff. When I first designed my experiment, I began with a realistic design, dropping the pH in each jar by only 0.1 every time. Then I realized that a realistic design would also have a realistic time frame, also known as a lifetime. I didn't have a lifetime to complete my experiment, and so I moved on to the exaggerated design. What I did was take 8 mason jars full of a mixture of salt water and vinegar, ranging from no vinegar in the first cup to a half a cup of vinegar in the next cup, all the way up to 3.5 cups of vinegar at half-cup intervals. Then I had 8 shells ranging from 26 grams to 52 grams, and you can see the rest of the equipment that I used at varying stages of my experiment. On to the procedure. At the beginning of the experiment, I filled the jars with salt water and vinegar, as per my design. Then I weighed the shells, so that I could compare the beginning weight of the shells to the end weights of the shells. The same thing for pH. I took the pH at the beginning to compare it to the pH at the end. Then I put all the shells in and waited. Every 12 hours, I took a measurement of pH, and then I compiled the data, as you can see down at the bottom in the 5th picture. This is the data that I came up with. As for pH, you can see that the pH in all the jars steadily rose over time, indicating that the basic shell material was dissolving into the acidic surrounding liquid. Now the spike in the pH I can explain by the first 12 hours, the shell was extremely agitated being dropped into the vinegar, and it dissolved as fast as it possibly could. Then it calmed down and had a more steady rate of climb. That's for the first bar graph. Now, you see to the right on the table that the differences in pH, the start pH and the ending pH, is exactly the opposite of what you would think. There's much more of a jump in the jars with lower acid than in the jars with higher acid. However, I can explain this as well. In the higher acid jars, there was more liquid overall, meaning that the effect of the dissolving shell had less of an impact than it did on the jars with the less liquid. This was a bit of an error on my part because that rendered my pH measurements slightly useless in terms of judging the effect of acid on shells. That being said, here are the shell weights that I took at the beginning and at the end, and this shows a definite trend in that more acid dissolves more shell material in the same amount of time as does lower acid. So, in the control jar, the shell lost no ounces. However, in the last jar, the jar with the most acid, it lost 22 ounces. Same for the second to last jar. This seems to corroborate my suggestion that higher acid levels in the ocean does more negatively affect the calcium carbonate shells of marine organisms. In conclusion, I have 2 answers. The shell weight says that yes, higher acid does contribute to more shell loss, whereas my pH is inconclusive because of my concentration gradient was off, and I cannot accurately measure the change in pH. But based on my research and my results, I am prepared to say that yes, rising acid levels in the ocean do negatively affect the calcium carbonate shells of marine organisms. Thank you very much for your time and for listening to my presentation.